Let's start solving maximum product subarray. Reading the question says, given an array ARR that contains positive and negative integers, may contain 0 as well, find the maximum product that we can get in a subarray of ARR. And one note is given here. It is saying that it is guaranteed that output fits in a 32-bit integer. That means we do not need to take care of the overflow. We would not be having that big of integers. So let's try to understand this question with an example. Let's see the sample test case. This one. You're given an array ARR. It says it's -2, 6, -3, 10, 0, and 2. Now out of this array, you now need to choose one subarray such that once you multiply all of the elements of that array, you get a product, and which is maximum of all the subarrays that you might possibly have. In our case, let's suppose we take this array, -3 and -10. Well, it would give us the answer 30, and that is going to be a positive. So yes, it is still a bigger number, but can we have a bigger number than 30? Indeed, we can. Let's suppose we include 6 as well. Then what will we have? We would have 180, right? Quite a big number. Can we take any bigger subarray than this? Let's try to include this element. If we include this element, then what will happen? We would get 360, but keep in your mind, a negative symbol is here with 2. That means it would be -360. And it now becomes a very smaller value. What we are looking for is the maximum subarray sum. That means we need to take care of the negative and plus sign as well. Now, I hope you have got the question, what the question is saying, what is it asking for. We are finding maximum product subarray. Again, quoting it again, we do not need to actually give the subarray, we just need to give the product, the maximum product possible. Checking this condition up, here in this array, you can see 60 is the answer because this is the only possible subarray that we can take. If we try to multiply these ones, let's say if we take this array, this subarray, it would be +30. If we try to include this one as well, we would have -30. We cannot take that. We cannot include 0 as well in our subarray because multiplying anything with 0 would end up being 0. Quite understandable. Coming on to this array. Now, what is the special with this array? Well, you can notice that all of the numbers here are already positive. And when you know that all the numbers are positive, that means at that point, just multiplying all of the elements is going to be your answer. I hope now all of these 3 test cases are clear to you. Let's try to build our logic around it now. Now let's work on this example. So here, as you can say, we have already seen this test case. How can we deal with the very basic approach? Okay, how can we form the most basic brute force here? Well, the simplest thing is going to be that you make up all of the subarrays, okay, and you find product of all of the subarrays, and out of those, whichsoever is maximum, you keep that, and then you return it as the answer. So it is just going to be how much time you take for generating all of these subarrays, right? Suppose you're taking this -2, then you can hold your I loop here, and then you can go for making up all the subarrays which begin with -2. So it could be -2 and 6, then it would be -2, 6, and -3, then including -10. Then once you include 0, everything would be 0 in the multiplication. But yeah, after that also, once you include something, everything would be 0. But you would have the value so far that you can keep the track of. Okay, 0 is never going to be, the bigger value because you have better cases there. Now, once all of the iteration with I being at -2 is done, then you move your I to the next position, this one. And then you again do the same operation from this point. You pick up 6 and then you try to make all of the possible subarrays which begin with 6. 6, -3, 6, -3, -10, 6, -3, -10, 0, and then 2. You don't actually need to store these anywhere. You just need to calculate your product, okay? Just have a variable with your multiplicative identity, I mean 1, and then you can simply multiply it, and after every jth loop's execution, you can check that you can actually maximize it any other result or answer variable. But how much this approach is going to be costing you in terms of time? Well, you are simply using this nested looping structure. Once you have this, you are performing the work which is requiring order of n times, ending up being order of n square. Too much of time complexity, we really want to reduce it. Okay, the question is not going to be passing all the test cases in this complexity. Fine. So now thinking about what can be the better approach. Well, if you've already done maximum sum subarray, then you can already start thinking about it, because it is, I won't say the same solution, but it is kind of similar. You can map your thoughts and you can align your approach accordingly. So coming on to this approach, here we will be keeping track of maximum ending and minimum ending of this subarray. What do I mean by that? Well, let's suppose we are going to start our iteration from this point and we will go till this, okay? And my motive is to just take one iteration to find my answer. That means I would be making up my subarrays from this point. And whenever I don't, I feel like the values are not necessary, I would also be skipping those. Now, once I try to include this ith value, what should be the main motive behind it? Let's suppose, completely just think in a very intuitive manner. Let's say we have -2 and we're including 1. Once we include it, we have -2 as the answer. So for us, let's say it is actually smaller than 1, but let's consider negative 2 for the time being. Then we have to include -3. What will happen? Well, if you try to multiply that, then it will become 6. Well, did you notice a sudden change from a negative to again a very again a bigger positive value? Because till this point, 1 was your bigger value. If you multiplied it with -2 and you try to take if you try to take this chunk, then it was getting a smaller value. And once you try to include one more value, which in this case is actually negative, these negative values, when multiplied, became a positive number, and that to a bigger one. Let's try to include one more value here, 4. It'll become 24. Then we can, we have -6 here. If you try to include this once more, then what will happen? We would have a negative symbol in our answer, and though big with the magnitude, but it is going to be of negative symbol. We don't want that, right? Eventually a smaller value. So for us, particularly this example, the answer would be 24. Well, actually, I did not take this correctly, just to give you the example. So if we take it carefully, so out of these two, you would choose 1 because that is a bigger value, correct? 1 multiplied with -3 would not be considered. Then -3 and 4, that would be -3 multiplied by 4, it would be -12, won't be considered. But only when we take this complete chunk, we can go to our answer, which would come out to be 24 anyways. But you need to keep in mind that we cannot keep the track of maximum value always, because at this case, if you were to take only the maximum values and you want to include every ith value, considering that every next step you take, you're just going to carry the maximum ending with you or the maximum value with you, then you might not lead to the correct answer. The same situation is here. Maximum answer you get is 1, but you also, if you consider this -2, there would be one minimum answer. Try to think of it in a number line. Your maximum answer is going to be lying somewhere on this side at any extreme end. Your minimum answer is going to be lying somewhere on this side on the left extreme end. The moment you get any ith value, which is a negative number, and when it will be multiplied with this one, there are chances that you get a larger number than this one that you already have. So just to keep this chance, what we are going to do is at every point of time, we would consider both of the values. When we are choosing up the elements, whether we have to consider this or not, we have to choose up both. That we are keeping, we will be keeping the track of the minimum ending and the maximum ending as well. Okay, let's try to see it in this example, that how are we doing it. So now we have 3 variables: current minimum, current max, and maximum product. Otherwise, you can name it as maximum end or maximum minimum end and maximum end. Up to you. Just the variables. Notice one thing. Initially, all of the 3 variables are marked as the ARR 0. We're going to be beginning our iteration from this point till the end. Now, once we have to, let's say we are choosing 6, what is going to be the parameters? We have to take care of these 3 variables. We have to provide new values to these 3 variables. Let's say if we include 6, what will be the impact on current minimum, what will be the impact on current maximum, and what will be the impact on maximum product. Maximum product is just the maximizing variable. So we have 3 situations. What? Let's say we just consider 6. We just consider 6 as the subarray. Otherwise, whatsoever current minimum that we have, in our case it's -2, we try to multiply that with our ith value. Or there could be one situation that whatsoever current maximum that we have, in this case -2, we try to multiply that with our ith value. We would have three values, correct? We would have three values. Out of these three, we need to first of all find maximum, so that whatsoever we get, we can put that in the current maximum for the next ith value. And we will take minimum out of these three values so that we can put that here in the current minimum for the next ith value. Once we are done with that, we also need to keep in mind that when we are choosing the maximum of this, using this maximum value, using the current maximum value, we are also maximizing this variable max product. Moving ahead to the next ith value, -3, this one. Now you can see, once you have considered 6, what was the situation? Once you have considered 6, you had two possibilities. 6, and you multiply that, then you would have 12, -12, and there you would have -12. So in this scenario, your current minimum would be updated to the minimum of these three values, which is -12. Your current maximum would be updated to maximum of these three values, which is 6. And because your maximum product value is maximizing, that would now change to 6, because previous it was -2, right? Now once we are to choose -3, again we have three situations. What? -3, the number as it is, comma, minimum one, -18. Actually, hold on, -18 is not calculated here. This one. The minimum one that we have previously is -12. -12 multiplied with -3, notice here, or the maximum value that we have, 6 multiplied with -3. We have these three situations: current minimum multiplied ith, current maximum multiplied ith, and the ith value. So out of these three, which would be the maximum value? This one, resulting in positive 36, right? That is what we are going to store in the current max. Minimum out of these three. Well, you can see you have -3, but you also have -18 here. The smaller is -18, thus current minimum will now have -18. And because we have encountered a bigger value in current max, my maximum product will be maximized. Like whensoever a bigger value comes in current maximum, I put that value in maximum prod, or you can say maximum product. Now, so far it's done. The next one that we have to take under consideration is -10. Let's see how that goes. For that situation, what are the possibilities? Again, tell me. The ith value that we have, the current minimum that we have, -18, multiplied with -10, comma, the current maximum that we have, 36, multiplied with the ith value. Once we solve this, what will be the maximum value that we get? This would turn to negative. This is already negative. This negative will become positive and would give us positive 180. That is what we are going to now set as our current maximum. And then here, you can see only one symbol is here, one negative symbol is here. Then this would turn to -360, which will be now our current minimum. Because again, we have got a bigger value in current maximum, my maximum product will increase, will be updated. Now coming on to the case where we have 0. So once we choose 0, all of these three values are going to be 0, right? Because 0, the ith value, comma, current maximum or current minimum multiplied with 0, it would result all of the values being 0. Minimum out of these is going to be 0. Maximum out of these will also be 0. That is what we are going to update as a current minimum and current maximum. Notice maximum product, now it is 180. It is not getting updated. Why? Because we are maximizing this variable. Now coming on to this last value that we have, 2. So for that, again, the same thing will happen. I would have the ith value that I have, or multiplying the minimum with the ith value, or multiplying the maximum with the ith value. In any ways, the maximum value that I would get from here is going to be 2. The minimum value that I would get from here is going to be 0. Will the current maximum affect my maximum product? It would not, because we have already received a bigger value here. Okay, so once our iteration is done, with the concept of minimum and maximum, we have achieved our answer 180, which is the correct answer. Correct? Remember the intuition, we are taking care of both negative and positive values because we are talking about the extreme ends in a number line. Okay, I'm supposing that my big positive number would be lying somewhere here. A big negative number would be lying somewhere here. Any ith value that I get, that may be positive or that can be negative as well. If it is positive, then the maximum value that I have, the current maximum that I have, that can get multiplied and make an even bigger value. Otherwise, if that is a negative value, then my negative n, or you can say the minimum value, right, that can get multiplied with it, and that can make a bigger positive value. Okay, so you got my point. Now let's try to see the code for the same. So here's the code. I'm keeping the track of n here. Then I have three variables: current minimum, current maximum, and the maximum product. Initially, put in the value of ARR 0, as we have seen already. Then we are iterating through an array only once, okay, from 1 till the end. Every time, what am I doing? I am taking these three values. What are the values? ARRI, the ith value we are working on, ARRI multiplied with the current maximum, and ARRI multiplied with the current minimum. Out of these three, whatsoever is maximum would be stored in current max. I am taking help of this temporary variable because make sure if you update your current maximum at this point, you would be using it again in the next line, and that would create an error. Okay, and that would create a logical error. So that is why I'm using this temp variable here. It is helping me out to just stay away from those errors. Now, like say the same thing with the minimum. We are just taking minimum of these three values. Okay. Now we have current minimum and current maximum ready. The last step is to maximize our current maximum, maximize the maximum product with the help of current maximum. So once I'm done with the execution, once I'm done with the one complete iteration of it, then I can simply return the maximum product that we have found so far. All right, so how much time complexity is this approach taking? Well, we are merely traveling in the array once, right? Thus, if the length of the array is n, then we can say that the time complexity that this approach takes is order of n. Are we using any extra space to store our answer here? Any extra array or any space that is growing with our approach? Well, no, we don't. So the space complexity is order of 1. Okay, this approach is very accurate, and this is one of the acceptable approaches. But well, there is like one more way that we can think of. This is more of a algorithmic way of approaching this question. But if you try to think logically, and if you want to, like intuitively form any other approach, then you can. You just need to have a few observations. Let's see it in the approach number 3. Let's say we have this example array. So here we have a few negative values and the other ones are positive. Now, if I try to take this array, then what will be my answer? Well, you know that you have two negative symbol here, right? So that would turn into a positive number, and that could be a possible contender to our finding the maximum product race, correct? But what if I extend it with 10? Well, still there are only two negatives, okay, which would, when multiplied, would make a positive number, and that would be multiplied with one more positive. That means even bigger value. But things change once we introduce one more negative value. Whatsoever big number that we have built so far, that would be now turned to negative. That means somehow, once we have this idea, we need to avoid this number, shouldn't we? Because if we won't, then I would lose the big number that has formed so far. Why is it happening? The reason is even and odd number of negative values. If your array has even number of negative values, then surely you can take all of the elements because eventually it is going to turn into a positive number. The problem occurs when you have odd number of elements, or sorry, odd number of negative values. At that point, you might need to make choice. What sort of choice that could be? You have this array, you have odd number of negative numbers here. Then in this case, you must avoid one negative number. Now, which numbers can we avoid? Let's say if we avoid this -2, then I can take this leftover array, right? I can take this leftover array, and then I can have some summation of it. I can like maximize it. What if I ignore -2, like I take -2 under consideration, but I try to ignore -3? Then in that case, we have two possibilities. We can either take this subarray or we can take this subarray. In both of the case, for our specific example, we only have one negative. That means odd occurrence, odd number of negative values here. So this will turn to a negative number eventually, signifying that -3 might not be the best negative value to not take, okay, to avoid. Now let's do the same thing with -1. Can we somehow avoid -1? Yes, if we avoid -1, then we have two possibilities. First one is going to be this, that you can only consider 3. The other one could be you consider this chunk. So for this specific question, for this specific example, we can avoid -2 and we can take this chunk here, because then again we have 3 bigger than that. So this is going to be the maximum product subarray. But what observation have you made so far? You know that we have the thing of even and odd number values or odd number of negative values going on. Even would always give us a positive, odd would always give us a negative value. That's for sure. Now we, in the odd case or in any all the cases in general, we need to take care of the values which are going to be left by us, so that we can form a positive number with all the leftover values. Now every time you pick the value, there were two possibilities. Either you were taking the left subarray, the left side of it, either you were taking the left side of it, or you were taking the complete right side of it. In other words, you can say either you were taking the prefix of it or you were taking the suffix of it. That's what you were doing. So at every point, you just need to check this. You just need to check this. For every point, you just need to keep in mind that we have to form one answer in this direction. We need to form one answer in this direction. Whatsoever, like when we are growing our array, when we are taking new number and we are trying to multiply that, then we need to keep on maximizing both the values, both the results. Okay, let's try to go towards left in this. -2 and this -6, once you have it, sorry, +6, what will it make? It'll make your -12. Then again, it'll be your 36, but of a positive sign. Then you would have 360, again of a positive sign. Then you would have -360 for this one. Then you would again multiply this with 3, correct? But the answer is going to be negative. That means a bigger negative value. So far, out of all of these, which is the biggest value that we got? We got 360, correct? But this may or may not be the correct answer. Let's try to go in this direction. We have 3, right? Multiplying it, -3. Multiplying this, -30. Multiplying this, it would be your 90. And then including 6. That would give you 540. Now tell me which one is bigger? 540, right? And now if you consider -2 again, then you would have a big negative value, which you do not want. So in this case, by making the observations of even and odd numbers of negative values and carefully seeing if we can avoid any of the negative value, because if we have any odd number of negative values, right, let's suppose we have 7 odd values, okay, we just need to avoid one negative value from it. Then we would have 6 negative values apart from that, and we can completely take that. We just need to avoid one negative in case of our odd number of occurrences. In our case, which negative value are we avoiding? We are avoiding this value, and we are taking all the leftover elements. Now that you have understood it, there is one more case that you must keep in your mind. Once you're taking 0, okay, suppose, let me extend this area a little. Now you have 2 zeros here. When you would be multiplying in this direction, then at this point and onwards, every value will become 0, which you do not want. So whenever you encounter 0, you actually would reset whatsoever multiplication variable you are taking to 1. Okay, the moment you encounter 0, this is a special case, the moment you encounter 0, you would create a new subarray from the next element. In this case, once we have zeros, we have 3 chunks: this chunk, and this chunk. Okay, when we are going from left to right, we are going to do this. When we are going from right to left, we are going to avoid 0 in this manner. Now I hope this approach is clear to you, right? Let's try to take a deeper look into that with help of one example. Assume this is an example. Here I have two variables, I and j, which will help me simultaneously calculate my prefixes and suffixes product. Okay, initially my I is set to -2 and my right, this j pointer is set here, which is my right to left, and it has value of 2. Maximum out of these two is 2 currently, so our maximum product is maximized and written as 2 here. Next, at the next step, when we move ahead and move both of our pointers, we encounter two values. For here, it is 6. So you try to multiply that. It would be negative 12. It would be negative 12. Left to right becomes negative 12. Once you try to include 0 here, this now would become 0. But would we consider 0 further? Let's see. We have maximum product out of these two, like out of the previous values, maximum product is still getting maximized. Okay. So previous value 2 was there and you have not encountered anything bigger than 2. Thus it is going to be 2 still. Now going ahead, once we come to this point and you have your jth value is 0 and you're moving ahead, you're not going to multiply that value with the next one. You're going to start a new subarray from here. So in this case, my right to left has negative 10 because we have avoided this, and taking this so far we had 12, but now we have multiplied, we had negative 12, but now we have multiplied negative 3 here. Then this chunk would be 36, right? Positive 36, that is what we have in left to right. And we have maximized our product, okay, max product. We have updated the value here. Now going on ahead, my j would come here. Right to left was negative 10. Now it has become negative 30 because it is positive 30 because it is multiplied here. You can see my I was having a positive 36 here so far, but in this direction, once I moved and included negative 10 here, it became negative 30. It became negative 30, right? So 36 is still the value that we have got so far, the biggest value that we have got so far. Now again, moving one more step. In this direction, my j is working. I had 30 multiplied with 6. Okay, I got 180, a positive big value, which is kept here. Now, once I include 0 here, in this direction, left to right, what will happen? My right to left would become 0. Maximizing max product, I know 180 would be the new value for it. Going ahead, now I have negative 2 and this positive 2. So far, I had 180, a positive 180. But when I included negative 2 to it, it became negative 360. We cannot update this value yet. I comes here, the previous value was 0. We are not going to multiply that. So we'll just take this 2. This 2 is taken here. Is it bigger than 180? No, it is not. This 180 is going to remain there. And once the iteration is completed, what have we done? We have simply calculated our maximum product by it. And this is the answer, and we can simply return that. Here only, let's try to figure out what is the time complexity for it. Well, you can say that, okay, we are calculating the prefixes, we are calculating the suffixes, but it is up to you for that if you're using 2 loops or 1. We can do that in one single loop as well. So for only one time, I'm going from in this array, from this point to this point, and simultaneously, I'm coming in the reverse direction as well, but I'm not taking any extra iteration for it. So we can say that the time complexity that we have for this approach is order of n. Are we taking any extra array to store our answer, or construct our logic which is growing with our value of n? No, we don't have that. This the auxiliary space is going to be not utilized much, and we would have order of 1 space complexity. Let's see the code for this one. Very simple code, very intuitive code. I have kept the track of n. I have made this variable maximum product, for which I have given negative infinity initially, so that whatsoever new value I get, any bigger value, I keep on storing in that. I have made two variables here, left to right and right to left. Initially, what have I done? I have said, okay, this is the 0 condition. After it, whatsoever I have said that the left to right we are going to begin it from ARRI, beginning from 0. Left to right is 1, right to left is 1. Initially, what will happen? I'll start multiplying with this element, with whatsoever element kept here, whatsoever element kept here. And in both directions, I would move simultaneously. How am I moving simultaneously? Like this. I know the value of I is going to be going in a very regular manner, 0, then 1, then 2, then 3, and up till end. And we are just going to take n minus I minus 1 for keeping the track in the reverse direction as well. So once I have the ith value, once I have the jth value, I know I have to multiply ith value to my left to right. I have to multiply my jth value to right to left. Whatsoever value that we calculate, we have to maximize that with this maximum product. These three, out of these three, whatsoever is maximum, that is going to be kept, or you can say held on to till the end of our iteration. So once our iteration is done from this point to this point, order of n is a time complexity. After the execution of this for loop, we can simply return the maximum product, because so far we have found our answer already. Once we return that, that is going to be passing all of our test cases. Let's try to run this code as well. All right, so we have the same code here. Let's try to run that. Okay, so you can see for this particular sample test case, we are getting the expected output, right? Let's try to test it against all of the test cases. All right, so you can see it has passed all of the test cases here. Now we have seen two optimized approach in this question. For solving this, you can use either of those. Okay, approach 2 or approach 3, it is up to you. But make sure you try to understand both of the approaches. Okay, this is more of intuitive. That approach 2 is more of algorithmic. So whichever clicks to you, use that, and make sure, as I always say, take a few examples, dry run both of the codes. You would have a better clarity over it. And again, if you like the video, if you're following it constantly, then make sure you tell me in the comments. Take care.